I'm Will Kearney. I'm a graduate student at Boston University. I study coastal geomorphology, which is basically how the coastal landscape responds to various kinds of changes in the environment. We're on a part of Massachusetts, which is a small part of a larger system that they call the Great Marsh. So marsh is a kind of wetland, land that's sometimes covered in water. And the definition of a marsh is usually that it's covered in herbaceous vegetation, so like grasses and other kinds of things. And so the marshes that we're in are all salt marshes, which means they are fed by ocean water, essentially. And that water is salty, and so the plants that live on the marshes have special adaptations to deal with the increased salt. In the eastern United States, the most important plants are of the Spartina genus. So you get two main plants, the Spartina alterniflora and Spartina patens. Alterniflora has these kind of thick blades of grass, whereas patens looks more like hay. So this little pink plant in this otherwise brown and green landscape is Salicornia, which is a succulent, somewhat like a cactus, I suppose, on the marsh. The coolest thing, I think, about the Salicornia is that it is, of course, edible, and early settlers on the marsh, when they were haying the marsh for their cattle and things, would collect the Salicornia and pickle it and use it in salads and various things. The marshes that we're in are all part of a research site called the Plum Island Ecosystems Long-Term Ecological Reserve. And the point of this is to develop long-term measurements and data collection of a single environment, these marshes in this estuary. So the reason we're here, and the project that I work on, is called the TIDE project. And the goal of TIDE is to explore what happens when you have too many nutrients coming down to the coast. And the theory is that the fertilization causes these Spartina alterniflora stands that line these banks to devote more of their biomass to shoots rather than to roots, because they don't need a dense root network to go find nutrients in the soil if nutrients are being delivered to them by the water. And those roots, unfortunately, are what hold the banks together. And so when you don't have roots, the banks start falling apart. And we've seen in these marshes that are being fertilized that these banks are collapsing pretty regularly. So it's possible in some places that marshes can move. We know that they move fairly regularly, and one consequence of kind of human development of coastal areas is that we don't like marshes moving. And we build things that prevent them from moving, roads and seawalls and things. So in some places it's possible that the marsh could kind of move backwards into the forest and stuff that borders the marsh. And that's something that our research group is actively looking at in Virginia, for instance. But otherwise, these marshes don't have much else they could do. And so if they start collapsing, especially if they're collapsing kind of from the inside as these channels expand rather than kind of drowning as sea level rises, there's really nothing they can do, and the marshes will disappear. And that probably is not very good, because the marshes do very important things for people on the coast. They help protect, the rest of the coastline from flooding and things that you might experience during storms. They help kind of sequester a lot of carbon and a lot of nutrients that are exported to the coast, get taken up by salt marshes and the plants and bacteria and ultimately the animals that live in the salt marsh.